This is our second day that we're going to take a look at fractions. I mentioned yesterday that fractions are lots easier to multiply and divide than they are to add and subtract. So it's kind of natural to start with the multiplication and division, even though that's not what we usually start with when we think about those four operations. But it is the natural one to start with for fractions. So today we're going to do the addition and subtraction part. Okay? Sound good? All right. In order to add or subtract, this one really should say addition and subtraction because the statements are true for both. In order to add fractions, the denominators must be equal. If you don't have a marker, the marker's filtered around at some point. You might want one for our activity that we're about to do. So if we could kind of filter the markers back around again to get a marker that will show up on top of whatever color the colored strips are you chose. Okay, so yellow is probably not a best choice for a marker for this particular activity. So choose a darker colored marker. Okay, they're coming around. There's a couple of boxes of them. All right, I want you to pick one of the colored strips. One pair. So like if you pick orange, you have two oranges. If you picked yellow, you have two yellows in your hand right now. I want you to take one of them and fold them in half. Fold one piece in half. I should do this activity with you just for fun. All right. So here's my strip. And it's folded in half. Okay, so everybody has half folded in half. Okay, down the middle of your strip where it's folded in half, go ahead and draw a line. With the marker, with your pen, doesn't matter, just draw it in half. Okay, are we getting this sheet going around? Okay. Okay, so you have now one half on one side, one half on the other side. Everybody good at that? Yes. Okay, with a marker or something dark, if you don't use your marker, you can use your pencil, but you'll like it better at the end here if you use a marker. I want you to shade in half of the pit of your fraction. So this is equal to 1, this is equal to 1/2, right? So you're shading in half of what you just folded. One of the sides, not both. One side is now sort of shaded in. So it looks something like this. One of your strips. Everybody good with that so far? Okay, so we're all really good at like taking something and folding it in half. It's pretty straightforward. What are we laughing at? You don't know.
I'm excited.
Huh?
I'm excited.
You're excited. I'm so glad. That's wonderful. All right, you have another strip, the same color that you just used, right? Take that other strip and fold it in thirds. That's a little trickier to do, but I know you guys can handle it. You're doing your very best to fold it into 3 equal pieces. Nope, not like that. That would still not be right. All right. Apparently we need a visual demonstration. I can do that. All right, here's your sheet. And you're going to fold it into thirds, right? Right, so there's 3 equal pieces when you're done. Okay? Roughly equal. Okay, I'm not going to, it's not going to be perfect. It's okay. You're going to do the same thing. You're going to draw a line through them so you have 3 blocks. So you'll have of your sheet. Okay, we'll refold. You should have 3 equal pieces like this. Okay? And I want you to shade in one of them. All right, once they're shaded in, those two are going to go next in your notebook, just like my yellow ones. Okay? It doesn't matter which one's on top, it makes no difference. Just put one on top of the other. So far, all we're looking at is my yellow on top. All right? Can everyone see how I've got the 1/3 shaded in, I've got the 1/2 shaded in, and then just tape them in there. So as the tape comes around, tape those in to your notebook. Okay? Do it in the middle.
Don't start.
All right. Okay. Everybody good? After you've taped it in, go ahead and write the fractions value out to the side of it. So the way that I've got mine on my screen right now, this fraction is 1/2 and this fraction is 1/3. If yours are upside down of mine, totally fine. Just write the fraction value next to the fraction bar that you've just created. These are called fraction bars, by the way. What you just created is called fraction bar. All right, if you're still taping, totally fine. If you're not, go ahead and start writing with me. This is actually going to represent us trying to add these two fractions together. 1/3 and 1/2. Now, the problem is that the boxes are all different sizes. Well, not all, but they're different sizes. My top box up here this box is a different size than this box, correct? So I can't just add them together by sort of taking one of the boxes and setting it down next to it and filling in what's there. If I were to try to take this smaller box and put it in here, it wouldn't quite fill that extra space. And if I were to take this larger box and fill it here, it would not fill one space, but like one and a part of another one, right? So this is a problem. And the problem is that the boxes are different sizes. So 1/3 plus 1/2, when I try to add them together, the boxes are not the same size. So they cannot be added together as is. But, so you ever have those moments in your life where like there is absolutely no solution? I can't figure a way out of this. This will not work. Can't figure out why this is going on. And then all of a sudden, God shows you something that you didn't see before. Has that ever happened to anybody in here? I know it's happened to me. I actually gave a sermon in church. I know we're not really supposed to call it that but I'm not Baptist, so women can speak in church. It's totally cool. So I gave a sermon. I spoke in church at my church, and the whole title of the sermon was "But God." And it was all about how he led us down our path to adoption and how that ended up happening. And the story just keeps continuing. I mean, for me, the things that happened that have had but God's. The primary reason that we are in the process right now of DHS adoption is because a year and a half ago, unexpectedly, I was pregnant and then I miscarried. And so, Obviously, it was horribly tragic. It was absolutely awful, but God. Okay? So this is one of those but moments. Not drastic but moment. It's math, right? But it doesn't look like there's a way to actually do this physically with the diagrams. This doesn't work. The boxes are different sizes, right? I want you to do the exact same thing again with your piece of paper. Take 2 more colors. Again, I don't care which 2 you have. I want you to fold one of them in half and one of them in a third, and I want you to shade them in. So you're doing the exact same thing we already did. Same picture as before. Okay? Okay, are you guys have done? Okay, I want you to take the 1/2 one, the one that represents 1/2. Okay, and I want you to fold it in half. Just fold it in half like you already did. Okay, I want you to take that half, and I want you to fold this half into thirds. Okay, so you're going to fold into thirds just like you did before. You're just starting out with a smaller thing to fold. Fold the half into thirds, and it doesn't have to be perfect. Mine was just, I screwed up a little bit. It's a little bit over on one, a little bit bigger on one than the other one, but we're looking for estimations here, okay? So now I have this tiny little box. Do you have a tiny little boxes? At this point, they're narrower. Unfold them, and I want you to draw all of those creases in on your sheet. So what's going to happen to the 1/2 is that now each of the sides of 1/2 is 3 smaller boxes because you folded it into thirds. Does yours look something like I've got on the screen? How many boxes are now shaded in that diagram that you have? There are 3. And how many boxes total do you have? 6. Okay, so this fraction now has another name. We could call this 3 out of 6. I mean, it's still 1/2, but if we're counting boxes, 3 boxes are shaded in out of 6 boxes. So now take your 1/3 one. And I want you to take your 1/3 that you had already created from before and shaded. And I want you to fold it in half. So here's my 1/3. I'm going to fold my 1/3 in half. So now it's little bitty, kind of like the last one was little bitty. Okay? And then you're going to open it back up and draw those lines in there again. So each of the 1/3s are now cut in half. How many boxes are now shaded? 2. Out of how many boxes total? 6. Depending on how well you've done in terms of accuracy, might depend on whether you can make the next leap with me. But even if you can't, hopefully from the screen you can. What can you tell me about the size now of the boxes? They're all what? They both have 6. So what about the size of them? They're all the same. The boxes originally were not the same size, but I changed them, I manipulated them, and now I have new boxes, and all my new boxes are the same size. Agreed? So I actually could now, if I wanted to, take this box and I could move it up here, right? And I could take this box, I don't want you drawing this down because we're about to do it in actual physical form, and I could move it up here because the boxes are all the same size, right? And then if I looked at that one strip I have at the top now where I've combined them together, how many boxes are shaded in? Just in my top strip. 5, right? Right in this strip right in here, there are 5 boxes shaded in. Out of how many boxes total? 6. Okay, tape those in. I know some of you are already sending the tape around to do that, so tape those in next in your binder or in your book. Then you can chat with me. Oh, I already wrote that down. This is the one I meant to write down. So if we took this is what we did. So you can write it down or you can not if you think you'll remember it, that's fine. But if we take the 1/3 and we divide each box in half, we would have 2 out of 6. We did that, right? And if we take the 1/2 and divide each box in 3, we now have 3/6. And what we concluded is now that the boxes are the same size, each box is now 1/6. And you can see that when we have 2/6 plus 3/6, we actually end up with 5/6. So we will use either common denominators or least common denominators to be able to combine and simplify. So grab your last strip. Okay, you only need one of them. It was just the easiest way to get you to get them all the same size. You only need one of them. The other one's going to trash. And I want you to fold it in half and then in thirds, or in thirds and then in half. Do the same thing we've done. And I want you to shade in 5 boxes, because that's what we did. We created a new strip. Our new strip, we split in half, and then we split in thirds, which gave us 6 boxes. We had 2/6 represented by one of our strips, and we had 3/6 represented by the other strip. And if we now combine them, we end up with 5/6. My hope is that the visual demonstration we just went through will serve as a reminder to how important those common denominators are. They have to have the same denominator or we cannot combine them because the sizes are different. But if we can get them somehow to have that common denominator, we can simply add the numerators together. Is anybody waiting on tape? Is there any tape left sitting somewhere and it's not being used? Jack, is there tape on your desk? Okay, are you done with it? Tape. Okay, so if you're done with the tape, pass them forward. I think people are waiting to tape still stuff in. Or pass it around, whatever. Yeah. All right, so we're going to look now at actually adding some other fractions that aren't 1/3 and 1/2 together. The ones we're going to actually start with are already going to have the same denominator. So we aren't going to have to go through that part of it, but we'll very quickly move into ones that don't. So if you take a look at number 1, we're adding 1/10 and 3/10 together. Take a look back at the directions that hopefully you're writing down. I've put something in parentheses on the directions that are true whether the directions always tell you this or not. You're always going to reduce your answers at the end to simplest form. Okay? If they're already in simplest form, great. And if they're not, then we will do it anyway. So with 1/10 and 3/10, we already have the same denominator. So the solution will have something in terms of 10 in the denominator. You don't add 10 and 10 together, right? I had 2 6 on the previous slide and 3 6, and it did not become 5/12, right? It's still out of 6. So this is still out of 10. But I do add the values of the numerator together. And you saw that when we took our 1/3 and our 1/2, right? We added the 2 and the 3 that we ended up with on top, and we will add these as well. So what's 1 plus 3? 4. At this point, if it's reduced, we're done. Can I reduce 4 out of 10 any further? Yes. So how can they be reduced? By 2, yeah. And so if I divide 4 by 2, what do I get? 2, and then 10 by 2 is 5. So the answer would be 2/5. Number 2, same thing. Denominators are already matching, so they stay the same. Don't have to do anything to simplify that to start with. This one's subtraction. Doesn't make it any different. We're just going to subtract the numerators. What's 3 minus 1? 2. We're subtracting, not adding. Plus would be 4, but we're going to subtract. 2 out of 5. Is it already in simplest form?
Yes.
Yep, it actually is, so we're good to go on that one. And the answer is not always 2 out of 5. I don't know how I chose 2 answers that have both ended up being 2 out of 5. I just did. So in order, when two numbers don't have the same denominator, to actually be able to add or to subtract them, we have to be able to find common denominators. We talked last time. One way to do that is to simply multiply these two denominators together. 10 times 18 on both of them, and that works. But the numbers get pretty big. I mean, we would have to multiply 2 times 18 and 10 times 18 and 5 times 10 and 18 times 10. The numbers get quite large. So can you do it that way? Yes, you can. You will get a common denominator, then you can add them, and then you can reduce at the end. But it's actually a little bit cleaner. I'm going to undo this. It's going to be cleaner if we find a least common denominator. So let me remind you how you find least common denominators. I'm going to show you, I haven't shown you this particular method, so I'm going to show you a new one today. Last time I talked about factor trees. Most of you seem to recognize those from before, and those are cool. I'm going to show you another one. I'll do it from down. That'll work. And we're going to take the number 10. This one's a pretty small one. It'll be more evident when I do the 18. But we're going to do division. So what does 10 divide by? Any factor it divides by. Any prime factor is better. 2 is a good one. And it's 2 times 5. And when I get to that point, 2 and 5 are both prime, so I'm going to stop. I'm circling them just to keep track of them. 18 is a little more fun because we get to do more division. What is 18? What is a factor of 18? Maybe the smallest one. 3 is 1. How about I start with 2 just so that I am using the smallest one? But you could do it. You could do 3. What's 18 divided by 2? 9. And then could I divide 9 again? Yes, so I'm kind of building on my division block here. I could divide 9 by the 3 that Preston mentioned, and I would get another 3. And then there's no more division because these are all primes. Okay? It's just another way of doing a tree, that they're all a little bit more organized. I don't have different lengths of tree branches on them. If you don't like it, don't use it. That's fine. But what I want you to recognize is that some of the factors between the two numbers match and some don't. This one was 2 times 5. This one is 2 times 3 times 3. Right? So let's look for the things that match first. What matches between the two? 2. The 2's match. Is that it? The 3's within one match, but not between the two values. So like I'm trying to compare this with this. They don't have any more besides the 2 that match, right? Okay. What that tells me then is that this 5 here is what I need to multiply the other fraction by. I've got 5 out of 18. I can multiply this by 5. okay? The other fraction had 2 3s down here, yeah? So I need to multiply the other fraction by the 2 3s. What's 3 times 3? 9. So I have 2 over 10, and I'd be multiplying them by 9s because those are the factors that they're missing to match the other number. So this problem doesn't ask me to actually add the fractions together. It just asks me what the least common denominator is. What do I get when I multiply the 18 by 5? Does anybody know? Okay, let's do the one you do know. How about 9 times 10? 90. Now try 18 times 5. What is it? It's 90, actually. It's the same. It should be, or we've made a mistake. It's 90. Okay? If I had simply multiplied the 10 and the 18 together from the get-go, I would have gotten a bigger number than that, right? 180. It would be larger because I would have multiplied basically by these matching 2's twice. So what I'm doing is I'm trying to break the number down in some fashion. If you don't like my trees, you can use your other trees. This is 10. It's 2 and 5. This is 18. Maybe you go with 3 and 6, and then you get 6 going down into 2 and 3. You're still looking for what's in common. The 2's are in common, right? And the 5 is what's missing from the 18, while the 3 and this 3 are what are missing from the 10 in order to make them match. That's our goal. So we're going to actually do the process now of finding least common denominators with the purpose of being able to do the addition or subtraction. We want the denominators to be the same. We can do it by multiplying the denominators together, or we could do it by finding a least common denominator. Some least common denominators are very obvious. Hopefully number 4 feels that way to you. I have a 3 and I have a 6. Say it for me. I could multiply the 3 times the 6. I could, what was that? I could make the first one 6, and that's probably the shortest way to do the problem. So if you think about the 3 and the 6, 6 is actually just 2 times 3. So if I just multiply the 2 times the 3 in the first fraction, I'll have the same denominator, right? So are there other things that I could do? Yeah, I mean, they both, if I multiplied them by different values, would get to different places. I could get them to be 18. I could get them to be 12. I think 12 is the one you thought of. Those all work. This one's just the shortest way of doing it because it's the smallest number to deal with. If I multiply the denominator by 2, I need to multiply the numerator by 2. So this first fraction is equivalent to 4 out of 6. So I've got 4 out of 6 plus 1/6, which is a total of what? 5/6. Once the denominators match, I'm able to add them. Now 5 is a little different. I mean, 6 is just double what 3 was, but 8 and 3 don't have that property, right? If I tried to do what I did on the previous screen and I factored the 8 down, 4 and 2 and 4 is 2 and 2, 3 is, already prime. Nothing matches, right? There are no common factors between 8 and 3. Well, I mean, they both divide by 1, but that's not especially helpful right now. They don't have any other common factors. So, what's the only thing I could do for this? Just multiply them together, right? I need to multiply my 3, it's a little too thick, by 8. And I need to multiply my 8 by 3. And of course, if I multiply the denominator, what do I also have to multiply? The numerator. So this one also gets multiplied by 3. And this one also gets multiplied by 8. So let's take a look. What is 5 times 3? Sorry, just a second. It is 15. My screen's delaying on showing you. Oh, there it is. Okay, good. All right, it is 15. The denominator, what is 8 times 3? 24. I've got a subtraction sign here. Now I have 1 times 8, so that's 8. And again, the denominator, 3 times 8, which is 24. The denominators match, so I know the denominator is now a 24. What will I do for my numerators? Subtract. 15 minus 8, 7. 7 out of 24. Does that reduce any? Nope, that one's done. Okay, I would like for you to try this one on your own. 2/7 minus 1/9. After you get a solution, compare with a neighbor and see if you got the same solution. Okay, I see less writing, so chatting should be happening, right? Turn to neighbor, somebody nearby you, and compare. See if you got the same answer they did, and if not, see if you can figure out where the errors might have occurred. Oh, really?
I never worked with it.
That's pretty cool. There's a really old movie you can watch that has it in it. Anybody seen Stand and Deliver? It's like from the 80s, so I say it's really old, but the picture quality is pretty sketchy. I'll say that. He does that in there. Okay, what answer did you guys get?
11 over 63.
11 over 63. So it sounds like you guys all got the same thing. Excellent. Do you need me to go through it, or are we good? We're good. All right, so let's take a look at a couple other things. We're going to talk, I mentioned last time that we would talk about this time, talking about converting to a mixed number. For the purposes of doing calculations, mixed numbers are just, they're awful. Hate them. They're not useful to me at all. I don't like mixed numbers. But for the purposes of actually having some concept of what value that is, how far that is, what that really looks like, mixed numbers are really useful. So if I tell you that I ate 15 halves cookies, you would look at me and say, okay, like that's a weird way of saying that, right? It's really weird. We don't talk like that, do we? But someone might actually say I ate 7.5 cookies. It'd be a lot of cookies and they might be sick. But that's how we say that, right? So a reminder about how we do some conversions. So we're going to end this particular section of material with how we convert between different number representations. So converting from mixed numbers into improper, or from improper fractions into mixed numbers is one of those ways. So how do we do that? Well, it is just division. This actually means 15 divided by 2. So if you were trying to do this, we would take 15 and we would divide by 2. How many times does 2 go into 15? 7. And if I multiply 7 times 2, I get 14. So I have a remainder of 1. So when you're really first learning to do division, about 3rd to 4th grade, you put things down that looked funny. They look like this, 7R1. Do you remember doing that? Yeah. And then somebody told you along the way that that means I have 7, and this 1 at the bottom is really still divided by the half on the outside, the 2 on the outside. So this is 7 1/2. So if somebody eats 15 halves cookies, they've eaten 7 1/2 cookies. All right? 7 1/2. What if you want to convert to a percent? So if you have a fraction and you want it in percent form, what does that look like? Well, there's a couple of different ways that can happen. So the general idea is, if possible, you could move decimal places. I'll explain that with this particular problem. But sometimes you just have to go back to division and then moving decimals after that. So the word percent actually means per 100. So if you think about it like a cent, a penny, how much is a penny worth out of a dollar? 1/100th of a dollar, right? It's 1/100th of a dollar. It would take 100 pennies to get to a dollar. Agreed? Yeah. So per cent, the word cent actually means per 100. It's 1/100th of something. So this number, this particular example that I've got on the screen right now, 14 over 100, is 14 hundredths, which is the same as 14 per cent. Now it's kind of special. I mean, the only reason that worked is because the denominator of the fraction was what? 100. So if I could turn the denominator into 100, that would be pretty nice. And some fractions are really easy to do that with, right? Like if I had 4 out of 5, would it be pretty easy to turn that 5 as a denominator into a 100? It would. What would I need to multiply by? 20, right? I could actually multiply this by 20. It would turn into 80 over 100. And this would actually be 80%. But what if I had something like 3/8? That's not quite so friendly. I mean, what would I multiply 8 by to get to 100?
Could you do 2 separate things?
Like what?
Like multiply by 2 and then go from there? Like multiply the top and the bottom by 2?
You could. I'm not sure that it would be helpful in this particular one, because if you multiply the denominator by 2, you get 16. That one's really not so nice to work with either. But you could do something in multiple steps. That wouldn't be a problem. So there are some problems that are trickier. Sometimes maybe even almost impossible to do that with, right? To just switch the denominator somehow to being over 100. So what do we do then? Well, that's the part up here where it says divide when necessary. So let me show you what happens when you can't get the denominator to be 100. And the kind of nice thing about what I'm about to show you is it works even if you could have gotten the denominator to be 100. So let me show you. You're going to divide. We're doing like we did over here where I talked about division, okay? So the 3 is going to be divided by the 8. Now clearly 8 does not go into 3, a whole number of times, right? I mean, it's bigger already. So you learned when you were first working with decimals that you could put a decimal point and you could treat this like it's the number 30. We'll do more with decimal divisions and things later, but for the moment, 30. How many times will 8 go into 30? 3 times. And the 3 goes above the 0 in the 30. And the decimal point goes straight up as well. Okay? What is 3 times 8? It's 24. And for the purposes of what we're doing, we can ignore the decimal places now. We don't need to worry about them, just ignore them. What's 30 minus 24? 6. Now I still have 6 here. My goal is to get this to be 0, so I'm going to do it again. I'm going to put a 0 here, and I'm going to bring my 0 down. How many times will 8 go into 60? 7 times. What's 7 times 8? 56. And I would subtract 60 minus 56 is 4. And I need one more 0. This will be my last step because now I have a 40. And what would 8 have to be multiplied by to get 40? 5. It actually works evenly at the end there. So 5 times 8 would be 40. I have a remainder of 0. So I've actually changed this into a decimal. You might be like, okay, but you were trying to change it into a percent. That's not a percent, that's a decimal. And it is. 3 out of 8 is equivalent to the decimal. 3, decimal point, then 375. 375 thousandths is how you say that. But if you have a decimal, changing a decimal into a percent is really easy. All it takes is to move the decimal place 2. The equivalent of multiplying by 100 because it's 100%. So this would be 37.5%. And that's what we have, 37.5%. Now, let me just go back up here and show you that it works for the one before. Let's say, for instance, you started with a 4 out of 5, and you weren't thinking, hey, I could multiply by the 20 and get 100 in the bottom, and you were like, I'm just always going to do this division part, which you can. You can do that. Here's how it would look. You would do your 4 divided by your 5. You'd do that decimal point, and you would say this goes in 8 times. You'd move your decimal point up, and you'd have 40 here. So you'd end up with this decimal point, that's 0, of 0.8. So your 4 out of 5 is equivalent to 0.8, which when you move the decimal point 2 times, there's a 0 here you can't see, right? Becomes 80%. So it still gives you the 80%. A few more steps, I think, actually, to do it that way, but it won't hurt anything. It's not going to take you that much longer. So you can divide and then move the decimal 2 over. All right. I think one more. Converting percents into fractions. So sometimes we start with a percentage, and we would want to turn it into a fraction. If somebody said something like, what is 14% of 32, right? Think about discounts. Does anybody go to Kohl's? Everything's always discounted there, right? Like, you never buy full price at Kohl's. If you're not aware of that, you should be. Just wait, and then it's going to go on sale, right? Okay. So if you wanted to use percentages on their signs to try and figure out how much money you are paying, one way to do that is to use fractions. Another way to do that would be use decimals. We'll talk about decimals soon. So I want to show you how we would turn a percent into a fraction. So what you're going to do is you're going to place the value it gives you, 12, over 100. It's 12%. 12 per 100, right? Fractions. And then you're going to reduce. What do 12 and 100 both divide by? There's a couple of options we could go with. Somebody give me one. 2. Okay. 2 is very nice. I would get 6 over 50. But I think that it will go further, right? What else will it divide by? 2 again. What is 6 divided by 2? 3. And 50 divided by 2? 25. Will 3 and 25 simplify any further? No, they will not. And so we're done. Cool?
Yep.
What's so funny, Preston? Oh, something about SpongeBob. All right. I would not. My kids didn't quite hit SpongeBob when you guys did. Yeah. My oldest one was a little bit too old when he came home to have hit that for you. So, all right. that's it for today. Don't leave.